Welcome to the McDaniel College Lab Safety Training. Today we will be talking about safe practices within the laboratories to help ensure your safety and health. Our goal is to ensure that you go home at the end of the day the same way you arrived this morning. Employee and student responsibilities. You must perform work in the safest manner possible. You must follow all college policies and procedures. The Forms and Policies page can be found on the portal under the Faculty and Staff Resources. You must report any health or safety hazards to the Office of Risk Management and EHS. It is the responsibility of the faculty member to continually train their student in all lab procedures. Dress code when walking into a lab. When walking into a lab, no matter what you are doing in that lab, you must be wearing the following: long pants and closed-toed shoes. Dress code when working in a lab. When working in a lab, you must be wearing the following: long pants that extend beyond the ankle, leggings, spandex pants, tights, and yoga pants are not acceptable substitutes for long pants. Closed-toed shoes that must cover the entire foot. No flip-flops, sandals, ballet flats, Crocs, or high heels. Long hair should be tied back, and exposed midriffs are not permitted. Personal protective equipment, PPE. Lab coats. Lab coats must be worn while working in the lab and must be fully buttoned. Chemistry lab coats are disposable coats made of Tyvek or a Tyvek alternative and are white. Use caution when working around open flames in Tyvek lab coats. Tyvek can melt when exposed to direct heat. Biology lab coats are disposable coats made of a non-woven fabric and are blue. These do not offer protection against chemical splashes. Students may also wear cloth lab coats in any lab. Personal protective equipment, PPE. Lab coats. Students should print their name in marker on the back of their disposable lab coat. Students should not share lab coats. Student lab coats are to be kept in storage bins in the designated drawers or a plastic storage bin within the lab. Lab coats cannot be taken back and forth between labs. Cloth lab coats must be laundered after each semester prior to the user removing their lab coat from the building. Personal protective equipment, PPE. Eye protection. Safety goggles have guards on the side of the face and a shield on the top of the goggles that meet the forehead. Prescription glasses and contact lenses do not provide protection. Safety goggles must be worn in the following scenarios: when handling chemicals hazardous to the eyes, when using chemicals with unknown hazards, when working with gases, working with liquids that are hotter than 60 degrees Celsius or 140 degrees Fahrenheit, when working with solid materials, i.e. glassware or equipment that may cause fragmentation or flying particles, when dust or fumes are present, and while working with preserved specimens during dissection activities. Personal protective equipment, PPE. Hand protection. Ensure that you are using the correct type of glove to protect you against the materials that you are working with. Rings should not be worn under gloves as they may puncture the glove. Remove gloves when touching any surface in common areas such as hallways, keyboards, doorknobs, elevator buttons, etc. Remove gloves when leaving the lab. Use a cart or a secondary container to carry hazardous materials in the hallway. General safety rules. Students may not remove any biologicals, chemicals, or reagents from the lab without the permission of a faculty or staff member. Do not use broken equipment. Place out of service and inform a faculty member. Keep cell phones, extra books, clothing, and personal possessions away from the lab bench to prevent contamination. General safety rules. Lab doors must be closed and locked when work is not being conducted. Use the buddy system while lab work is in progress. Faculty members must be aware of the work students will be doing. Projects involving chemicals on the high hazard chemical list must be conducted with a faculty member present. After hours work, faculty member must send a list of the student names and permitted room number to campus safety at the beginning of each semester. The student must call campus safety to be let into permitted room. Student must have a buddy and show McDaniel ID for access. Lab hygiene. Eating, drinking, chewing gum, applying any lip products, and/or makeup is not allowed within the labs. Do not put any pens, pencils, or gloves in your mouth during lab work. Wash your hands with soap and water whenever reagents contact the skin and before leaving the lab. Keep the lab clean. Wipe down the benchtop with designated cleaning material after each experiment. Work involving bacteria. Lab benches must be disinfected with an EPA-registered disinfectant after each lab experiment. Return chemicals and equipment to their proper places, dispose of trash, and make sure the drains are uncluttered. Housekeeping. The laboratory should be kept clean by wiping down the counter with the designated cleaner after each lab experiment. When working with bacteria, lab benches must be disinfected with an EPA-registered disinfectant after each lab experiment. Return chemicals and equipment to their proper places, dispose of trash, and make sure the drains are uncluttered. When using gas or vacuum outlets, make sure they are turned off before leaving the laboratory. Return any personal protective equipment to its designated location. Blackboard Safety Course. Students must complete the lab safety training on Blackboard by the deadline provided. The training and quiz are the same format as last semester. Lab safety agreements are electronic. Any student registered after the deadline will need to be added to the Blackboard course. Please let me know as soon as possible. Fume hoods. Face velocity should be around 100 fpm at the sash height of 18 inches. Ensure the sash is not above the sash line indicated by the certification sticker. Work with the sash between 12 to 18 inches high, depending on the user's height. Ensure all chemicals are in secondary containers within fume hoods due to the sinks. When using a fume hood, please look for a Kim wipe in the top left-hand corner that is used as a visual indicator that the fume hood is exhausting. If there is a problem with the fume hood, close the sash, place an out-of-order sign on the sash, and contact physical plant. Chemical inventory. It is a collective list of all chemicals in each lab and on campus. All chemicals must be barcoded. Remove barcode from chemical container when empty and place in the waste area. Katrina or Sean will remove the barcodes from inventory. Chimera, our chemical inventory system. It is reconciled yearly, and all faculty should have their own login for Chimera. Students can obtain access on a case-by-case basis. Our chemical inventory is submitted to the local fire department. Safety data sheets. SDSs. SDSs explain all necessary information for the chemical. Information on the SDS must be presented using specific headings in a specified sequence. It must be in English and must be readily accessible to all employees during all work shifts. They can be found in binders or through electronic access in Chimera. Chemical labeling. All chemicals must be labeled with the contents. The full chemical name must be written out. Abbreviations and chemical symbols do not meet regulation requirements. Household-grade chemicals do not need to be relabeled, as the manufacturer's labeling is adequate to communicate the hazards. Primary container labeling, otherwise known as the manufacturer's label, uses the Globally Harmonized System, or GHS, for the classification and labeling of chemicals. Workplace container labeling, otherwise known as secondary container labels. We also use the GHS, or Globally Harmonized System, for the classification and labeling of chemicals. Proper labeling under GHS. Signal word. It is a word that indicates the relative level of the hazard. Danger is used for most severe instances, while warning is less severe. Symbols. Hazard pictograms. These convey health, physical, and environmental hazard information with red diamond pictograms. They may use a combination of 1 to 5 symbols. Product name or identifiers must be written on the GHS label. Hazard statements. Phrases that describe the nature of hazardous products and oftentimes the degree of the hazard. Precautionary statements. Phrases that are associated with each hazard statement that describe general preventative response storage or disposal precautions. Manufacturer information. This contains the company name, address, and telephone number. GHS pictograms. Hazard pictograms and their related hazard classes. The following are all pictograms that can be found on any GHS labeled container from the top left to the bottom right. They are as follows: exploding bomb, corrosion, flame over circle, gas cylinder, environment, skull and crossbones, exclamation mark, health hazard, and flame. A DOT label is separate from that of a GHS label. A bottle will come with a GHS label on the container, and the box will be labeled with a DOT label. NFPA 704 Diamond. Fill in the chemical name with no abbreviations, owner, and date. The diamond must fully be filled out using Chimera. If filling in the diamond for 2 or more chemicals, look up the chemicals and take the highest number for each color. Chemical storage guidelines. All stored chemicals must be labeled. This minimizes the hazards associated with accidentally mixing incompatible chemicals. Never sort and store chemicals alphabetically. Store all chemicals by their chemical family. For example, acids, bases, flammables, etc. Ensure caps and lids on all chemical containers are tightly closed. Never store chemicals under sinks, never store chemicals above 5 feet, and never keep expired chemicals. If you have any questions on chemical storage, please ask. Cylinder storage. Always secure cylinders with straps or chains connected to a wall bracket or fixed surface, or place the cylinder in a rack or a stand. Always keep cylinders upright and keep them separated by compatibility. Ensure that they are stored in a cool, dry, well-ventilated area. Ensure that the usage tag indicates correctly. When cylinder is empty or not being used, please ensure that the valve is closed. Waste management. Different types of waste streams: hazardous waste, biohazardous waste, universal waste, non-hazardous waste, and radioactive waste. Each waste stream is disposed of in a different manner. Hazardous waste, radioactive waste, biohazardous waste, and universal waste are all carefully tracked. Please be conscious of all types of waste. If you are unsure of how to properly dispose of your waste, contact the Office of Risk Management and EHS. Hazardous waste. Hazardous waste is regulated by the EPA or the MDE in Maryland. Waste is considered hazardous when it shows characteristics of ignitability, corrosivity, reactivity, or toxicity. Listed hazardous wastes. The F list, a nonspecific source waste, for example, spent solvents. The K list, source-specific waste, for example, ink sludges containing chromium or lead. The P list and the U list, discarded commercial chemical products, such as sodium azide and acetone. Hazardous waste. The satellite accumulation areas can be found in many of the labs. Hazardous waste is held here until it is transferred to the central accumulation area. A contracted vendor will pick up all waste from the central accumulation area. The central accumulation area and satellite accumulation areas are highly regulated by the MDE. Hazardous waste, Title 40 CFR. The Resource Conservation and Recovery Act, or RCRA, requires the EPA to publicize and enforce regulations regarding the management of hazardous waste. The mandatory procedures for compliance must be followed by facilities where haz waste is accumulated, transported, treated, or disposed, otherwise known as cradle to grave. We are classified as a large quantity generator under the MDE. Waste must be removed from campus within 180 days of the accumulation start date. New setup for waste containers and labels located in 103, 301, and 208 for small, medium, and large containers. Ready for disposal labels can be found and picked up in 301 and 208. Chemical waste. Waste from lab courses may be discarded into the pre-labeled containers placed out by the chemistry lab manager, biology lab manager, or instructor. Waste from research labs. Place a hazardous waste label onto the container. Fill the label out completely with chemical contents, no abbreviations, amount, and accumulation start date. Place into the secondary container in the satellite accumulation area. As for chemically contaminated sharps, place them into the white puncture-resistant sharps containers and fill out the label with what the sharp is contaminated with. On this slide, you will see a hazardous waste label. As we have previously mentioned on the last slide, the hazardous waste label is required to have hazardous waste written on it in plain English. This can be found at the top center of the label. Moving down from the top, we have a line for the date, which will be the start accumulation date, the lab that the waste has been accumulated in, and the staff or faculty member that has began collection of the hazardous waste. Moving further down the label, you will see that there is a spot for you to write the amount, concentration, and substance that you have placed into the hazardous waste container. At the very bottom center of the hazardous waste label are the GHS pictograms, which you must circle depending on what you have put into the jar. Biological waste. Animal carcasses and tissue are collected in the labeled bins. Sharps, needles, syringes, blood tubes, etc. must be placed in the red puncture-resistant sharps containers. Autoclavable items are collected in the labeled bins with the clear bags. Biohazardous waste that cannot be autoclaved is collected in the biohazard boxes with the red bags. Empty containers. Empty manufacturer containers. Please leave empty manufacturer chemical containers in the satellite accumulation areas. Ensure that the barcode on the chemical is not removed from the container. Empty secondary containers. Remove or deface the label with a permanent marker. Rinse the container out. Or, if the chemical is a P-listed chemical, rinse into a waste container or place full container into the SAA. Other types of waste. Universal waste. For bulbs and batteries, please contact the Office of Risk Management and EHS for disposal. For non-hazardous waste, all non-hazardous waste can be placed into the trash unless otherwise specified. Gloves and paper towels, unless heavily saturated with chemical or biological material, can be placed in the regular trash. Non-contaminated broken glass should be placed into broken glass boxes, labeled cardboard boxes, which can be found throughout the laboratories. Hazard classification. The process of evaluating available scientific evidence in order to determine if a chemical is hazardous. This provides us with the basis for the hazard information that is provided on the SDS labels and employee training. This evaluation identifies both physical hazards and health hazards. Physical hazards are as follows: fire, such as flammables or oxidizers; explosion, such as compressed gas or explosives; reactive, such as organic peroxide or water reactives. Health hazards are as follows: systemic effects, such as carcinogens, toxics, or irritants; or target organ effects, such as reproductive toxins or neurotoxins. Hazardous materials entry routes. Now let's talk about the hazards you may find in the lab. Hazardous materials can enter the body in 4 different routes. Materials can enter through inhalation, which is through breathing and is the fastest way into your system. It is important that you understand what chemicals are being used when entering a lab, as some chemicals are odorless and can overcome you very quickly. Absorption occurs when a chemical is absorbed through the skin or eyes. This is why it is important to wear the proper protective equipment. Ingestion occurs when swallowing the material. Many people do not think about washing their hands after leaving the laboratory. But what if you had a microscopic hole in your gloves and you did not wash your hands before lunch or before heading home to your loved ones? It is important to think about these scenarios to keep yourself and others safe. Injection, which penetrates through the skin and can occur if a contaminated sharp is thrown into the trash and a custodial work goes to empty the trash. Please ensure proper storage and disposal of all materials within your lab. Types of exposures. There are two types of exposures, acute and chronic. Acute exposure is short-term exposure and symptoms tend to be seen quickly. An example would be a chemical burn to the eye or to the skin, as can be seen on the pictures of this slide. Chronic exposure is gradual exposure over time, where symptoms tend to be seen years down the road. An example would be asbestos exposure. Most people do not see the effects of asbestos exposure until 10, 20, or even 30 years after the exposure occurs. That is why it is important to understand what you are working with today, because it could have grave effects on your health years down the road. To reduce the chance of exposure, we need to identify the hazards, receive training, use engineering controls, workplace behavior controls, and personal protective equipment. Since people are exposed to chemicals with their work, the Occupational Safety and Health Administration, or OSHA, has set limits for the maximum levels of exposure an individual can be exposed to and not suffer adverse health effects, called permissible exposure limits, or PELs. Exposure limits are published and enforced by OSHA as a legal standard. OSHA PELs are based on an 8-hour time weighted average exposure and can be found in tables Z-1, Z-2, or Z-3 of 29 CFR 1910.1000, the SDS, or OSHA.gov. Clues that can indicate exposure. In some instances, there may be indicators to exposure to hazardous chemicals, such as odor, taste, particles in your respiratory system, acute symptoms, visible material in the air, or settled dust. Please seek medical treatment immediately if you have been exposed. On this slide, you can see the hierarchy of exposure control methods. First is elimination. If you can eliminate the chemical altogether, there are no hazards. However, that is not very practical when working in a laboratory. The next method is substitution. This consists of using different, less dangerous chemicals instead of highly dangerous ones. While these first two methods are the most difficult methods to implement, they are the most effective. Next, we have engineering controls, where you remove a hazard or place a barrier between the worker and the hazards. Examples of this include chemical, fume hoods, and biosafety cabinets. Using safe work practices and administrative controls helps the worker ensure that they are following guidelines created for them to keep them safe while completing their work, such as SOPs, or standard operating procedures, and proper housekeeping are examples. Personal protective equipment should be your last method used to control exposure. If you cannot work safely with all the other methods in place, you must use personal protective equipment. Examples of PPE include gloves, safety goggles, and respiratory protection. Lab hazard information signs. One of these signs must be posted outside of each lab. These signs are updated yearly, and they provide critical information including 24-hour emergency contact information, lab hazard information such as NFPA diamonds and GHS pictograms. Always read the lab hazard sign before entering a lab. Emergency procedures. In the event of an emergency in the labs, contact Campus Safety and the Office of Risk Management NEHS. Campus Safety. Dial 2202 from any in-house phone. Dial 410-857-2202 from any phone. The Office of Risk Management NEHS. Ethan Harden, Physical Plant. 410-871-3123. Katrina Weens, Eaton 304. 410-857-2489. Sean Wellman, Eaton 218. 410-857-2480. Contact information can be found on the lab hazard information signs posted outside of every lab. Medical emergencies. For incidents involving first aid and/or emergency equipment such as emergency showers or eye washes, please contact Campus Safety and the Office of Risk Management NEHS, then fill out the laboratory incident report and send it to the Office of Risk Management NEHS. Exposures. If you are exposed to a hazardous substance, inform someone immediately to determine the next step using the SDS or label. Flush the area with water for at least 15 minutes unless the SDS or label indicates otherwise. Contact Campus Safety and the Office of Risk Management and EHS. Always seek medical attention following an exposure. Once safe, report the incident to your supervisor. A laboratory incident report will need to be completed. Spill response. Students. If you can do so, block off any drains so that the chemical does not make contact. Remove others from the affected area. Close the door to the room to contain the spill, and report the incident including the chemical name to a faculty member who will clean up the spill or call for assistance. Spill response. Faculty and staff. Do not clean up a spill if you do not feel comfortable. Chemical spills under 4 liters. Remove others from the affected area. Ensure you have a buddy to assist you. Spill kits are located near each lab. Use the correct PPE to ensure you are protected from the chemical or biological. Choose the correct material to clean up the chemical or biological that was spilled. Spill response. Chemical spills under 4 liters. Continue. Ensure to block off any drains so that the chemical does not make contact. Use tools to pick up any broken glass. Work from the outside in, as shown below. All cleanup materials must be disposed of properly. Put into a bag/container, label, and place into the closest SAA. Send a laboratory incident report to the Office of Risk Management and EHS. Spill response. If the spill is over 4 liters or a highly hazardous chemical, evacuate the area immediately. Remove and notify those in danger. Close the door behind you and contact the Campus Safety and the Office of Risk Management and EHS. Student inebriation and lab safety. A student who is under the influence of drugs or alcohol risks both their safety and that of others. Signs of impairment include slurred speech, poor coordination, confusion, or odor of alcohol or drugs. Inebriated student policy. Students under the influence of drugs or alcohol pose a safety risk to themselves and others in lab. A student who is thought to be inebriated will be removed from the lab for their own safety. Campus Safety will then be contacted to document the incident and refer the student to the student conduct process. Training requirements. Training is required for employees who work within a laboratory, at the time of initial assignment, yearly, or whenever a new hazard is introduced into their working area. You have reached the conclusion of the training. Thank you for participating. We hope you enjoyed the training. Please direct any questions or comments to Ethan Hardy.